All right, for this section, I'm going to talk about domain and range, and we don't do a ton of this in calculus as far as like, here's a function, find the domain. However, the domain plays into some problems sometimes, like you might just have to know that that answer is not in the domain, so you shouldn't consider it, or things like that. And so that's why we're going to review it, is there's 3 specific instances you need to watch out for. And even though I won't specifically ask you to find the domain, this is like a good background skill for you to have. So the 3 instances that we're going to be concerned about are fractions and radicals and logarithms. And with fractions, the denominator should not equal 0. So that's what we're going to start off first, is we're going to look at the domain of a rational function. So for each of these 3 examples, we're going to find the domain. And example 1 is the rational function f of x equals x minus 4 over x squared minus 16. And so I don't care about the top, and when the top equals 4, the numerator. I just care about the denominator. So what I'm going to do is I'm going to factor that, and I can see that this problem is difference of squares. So I have f of x equals the x minus 4 on the top, but on the bottom, I know I've got 2 sets of parentheses, one with a plus, one with a minus, and I have to multiply to 16, so it'll be 4. X plus 4, x minus 4. So I can see that I've got these factors that cancel, which means that there must be a hole at an x value of positive 4. There must be a vertical asymptote at an x value of negative 4. But both of those values, positive 4 and negative 4, would be missing from the domain. So I've got 2 ways I can write this. Well, more than 2 actually. I can say all real numbers, but x cannot equal negative 4 and positive 4. Or I could say negative infinity to negative 4, negative 4 to positive 4, positive 4 to infinity. So this would be set notation, interval notation. In the set notation, you could also have written it as an inequality. So you could say x is less than negative 4, or x is between negative 4 and positive 4, or x is greater than positive 4. So 3 different ways of writing the same thing. The important part is that you're excluding the x value that would have created that hole and the x value that would have created that vertical asymptote. All right, example 2, same instructions, we're still finding the domain. This one, the function is a radical, so square root of 2x minus 9. In those radical functions, we only care about the even roots, square root, 4th root, 6th root. The odd roots, cube root functions, you can plug anything into those. It doesn't matter, you can cube root a negative. So here, we know that we can square root 0, but we can't square root negative numbers. So what we do here is we say whatever is underneath that square root needs to be greater than or equal to 0. So 2x minus 9 is greater than or equal to 0. The exception to that would be if you had a square root that was in the denominator, and then you would say it couldn't equal 0. So I'm going to go ahead and add the 9 over, and then x is greater than or equal to 9 halves, or you could say 9 halves to infinity would be your domain. All right, last example is going to be a natural log problem, and this would be the same if we were doing, I was going to say an unnatural log, not an unnatural log, but just a log with a base that's not e. So this one is going to be f of x equals ln of x minus 10, but it would have been the same if we said log base 5 or log base 10 or log base pi if you want to get fancy. So when you take the log of a number, you're good as long as that number is not 0 and is positive. So we can't log negatives, we can't log 0. So that means that whatever is inside of the logarithm has to be positive. So I'm going to say x minus 10 is greater than 0, is really what we're looking for. So add the 10 over, x is greater than 10, or you could say 10 to infinity.